Hey guys, welcome to Derivation Dudes. Today we will be doing the derivation of a parabola. We'll be doing two derivations really. We're going to be doing a derivation of a parabola where the directrix is parallel to the x-axis, and then we're going to be doing a derivation where the directrix is parallel to the y-axis. Hope you guys enjoy. So to start, we're going to have to draw our parabola. Obviously, like I said, we're going to make the first one opening upwards. It's going to intersect the origin of the coordinate system. That's its vertice right there. So obviously its vertice is 0, 0. Then we're going to draw a few things. We're going to draw its focus right here. I'm going to try and make this as even as possible. So hopefully you guys don't judge me too much for this. That's about right. So that's going to be our directrix right there. And then we're going to make another coordinate point right here. And to do this derivation, what you're going to need to do is you're going to need to draw a line from this point. We're going to call this point P. And we're going to give it the coordinates x and y. I know that's sloppy. Oh, so sorry. X and y. You know what? Let's redo it. Very sorry. Does not look good. That's better. X and y. So then from that coordinate, we're going to draw a line that intersects the directrix and is perpendicular. So perpendicular intersects. And this point right here, we can label it A, and it's going to be, obviously, if it's parallel, that means that it's going to be, if it intersects at the same point and this is perpendicular, this is going to be the same coordinate x. And then, because the directrix is at a coordinate, this is the equation for the directrix, because this is a line, and the equation we're going to give is x equals negative c. Thus, this point must have a y coordinate of negative c. Sorry, this should be y equals negative c, not x. That was my mistake, y. So now that we have that, we're going to also draw a line from the focus that intersects this point xy. And this point, because because the focus has to be equidistant from the vertex, just as the directrix does, we know that it's going to have a coordinate of f. We're going to label it f because of foci. And because it is on the y-axis, the x-coordinate is going to be 0, and then the y-coordinate is going to be c. So there, you pretty much have it drawn out now. And this, hopefully you understand all the different steps I did to create this graph and to create the derivation. Now we have to prove the formula. So we're going to start out with P F equals P A. PF equals PA is going to be the defining factor, how we prove that this parabola is real, that it can happen, and that we can find the equation, because we know that PF has to be equal to PA. Using this knowledge, we are then going to use the distance formula, which hopefully you should know. So we're going to do square root, and then inside here we're going to have x minus 0 squared plus y minus c squared. And if you're wondering why we're doing this, obviously it is because from here x minus 0, y minus c, That's the equation that we have to use. It's pretty simplistic. And then PA, we just have to do the same exact thing. Hopefully you've already realized what we have to do by now. So we're going to have to do x, x minus x squared plus y plus c squared. Easy. Again, obviously, if you look, x minus x, y minus negative c is y plus c. So that's how we got that. Now, we're just going to have to keep going with the formula. What we're going to do next is we're going to square both sides to get rid of that nasty square root sign. Now, at the same time, as I do this, I know, whoa, 2 steps in one. I'm going to also get rid of this because x minus x is obviously 0. Thus, we're going to have for our next step y plus c squared equals, here x minus 0, I hope that you can realize that that is, let me just erase this so it doesn't get in the way. Obviously x minus 0 squared. X minus 0 is just x squared. Hopefully you realize that. And then we're going to also just have the y minus c squared. Hopefully that's pretty obvious to you. Next, we're going to factor both these terms out. And if you do that, you're going to get x squared plus y squared minus 2cy plus c squared equals y squared plus 2yc plus c squared. Now it's time to simplify the equation. We see that we have c squared on both sides. That means we can get rid of it. So we're getting rid of that. Y squared on both sides. That leaves us with all this. To finish up the equation, I'm going to add 2cy to this side and this side. Thus, I will get rid of 2cy. So plus 2cy. Sorry that my c's are so bad. Plus 2cy. That's going to leave us with the equation x squared equals 4cy. And then from there, that equation, if you want to, can be simplified to y equals x squared over 4c. And there you go. You have just derived the equation for a parabola that opens upwards. Hopefully it wasn't too hard. One of the easier derivations. Next, we're going to do a similar derivation, almost very similar in almost all manners, except we're going to flip it around. So we're just going to erase everything here. Again, as before, we're going to make our lines. So just draw your Cartesian coordinates, simple. Hopefully I don't have to go as slowly as I've done the last time, seeing as how it's a very, very similar process. We are just switching it around. So this time we are going to have our parabola opening to the right instead of upwards. So this is a parabola that opens to the right. And our directrix, obviously, will also be, instead of being a y equals equation, y equals negative c, it is going to be x equals negative c. Hopefully you don't find this too complicated. Then obviously we're going to draw our focus. If this is negative c, the coordinate for our focus will be, hopefully you can guess. Yes, are you right? Are you right? That's right, negative, oh, no. Okay, looks like I wasn't right. It's going to be c, comma, 0, because it's going to be equidistant, as I said before. We're going to draw the same line we drew last time. We're going to call this point P, just like we did last time. Draw a line perpendicular. Let me redo that line. My goodness, that was bad. I'm going to draw a perpendicular line from here. I think my drawing is getting worse. I'm going to label this point A. A will be known as, well, let's find this P coordinate will be known as x comma y. Let's not get ahead of ourselves. Hence, then this A coordinate is going to be known as, because it's y, negative c, because it is on the directrix, obviously, negative c comma y will be the coordinate. Hopefully you understand why that is. Just like before, we're also going to draw a line from here to this coordinate as well. And very similar, just like last time, we're going to state that P F equals PA. So there we have it. We're going to start it out. What are we going to do? We're going to do, yep, you guessed it, another square root, because we're going to use the distance formula. Square root. Here we are going to have, extend that a little bit. So P of F, x plus, oh, my bad. Not x plus, what am I thinking here? X minus c squared plus y minus 0 squared. And then we're also going to have, for PA, x minus c is x plus c. I hope you can understand that. Squared plus, and that is a c, not a y. I'll redraw it for you just because I don't want you getting making a mistake there. So that's x plus c plus yep, y minus y squared. Again, just like before, incredibly, we're going to square both sides to get rid of the square roots on either side. And I'm also going to make 2 steps in one. We know obviously that y minus 0 is just going to be y squared. And then we're going to have x minus c squared as well. Did I change colors? No. Just delusional. X minus c squared plus y squared equals x plus c squared. And obviously, hopefully you understood this as well, y minus y squared is going to equal 0. Therefore, it's null. We don't need to put it. We're going to factor out both these equations. X squared minus 2xc plus y squared equals x squared plus 2x c plus, oh, my mistake. This was supposed to be x plus y squared. Hopefully X plus c squared, my bad. Yeah, no, oh my god. What am I doing to myself? That is x plus c squared. X plus c squared. I am being delusional. LOL. So there we have it. You can get rid of both x's because they're going to null each other out. Add 2xc to both sides. And I also forgot to write plus c squared over here. My bad. Obviously, when you distribute this out, you'll get c squared, but this is also going to be null. So therefore, this is going to be null as well. You're going to be left with 2xc, 2xc. Add 2xc to both sides. You're going to be left with y squared equals 4xc. And you can either leave it like that, or you can put it into another form, which is x equals x equals y squared over 4c. There you have it. That is your derivation. So that's how you prove for both this, a parabola that opens to the right and a parabola that opens upward. I think as long as you know how to draw the graph, as long as you know all the different steps, it's a very simple derivation. There's much more complicated ones that we will get to later. And I hope you guys enjoyed the video. Thanks for watching. Hope to see you soon.